Okay, this lesson is the limit comparison test, which is significantly easier to apply. It's still a pain in the neck, but you have to do this one. It makes doing a test that comes later a little bit easier. But the gist is this, like before, you're going to come up with two, the one you start with and the one you're going to create to compare with. Okay, now this time you're not going to have this inequality nonsense where one is bigger than the other. As I said in that video, it is very difficult as a general rule to compare. Like for instance, I'm gonna make the comparison one here. I'm gonna call this one AN, and I'm gonna make my BN. The way you do it is very simple. You ignore everything except the highest power on the top and the highest power on the bottom. And then you simplify it. You end up with a p-test, always. Oh, that's the whole point of doing this. Even if there were numbers here, you would ignore them. Get n squared, n4, subtract the powers, right? You get 1 over n squared. So that's going to be my comparison. Now, I know that this one converges by the p-test, right? P is greater than 1. I don't like the way my S turned out there. So converges by the p-test. Now, I don't have to worry about this. This would be very difficult for me to show that one of these is bigger than the other. I'd have to sit there and try plugging in numbers, or I'd have to try to create some really convoluted inequality that's too complicated. And that's the point. That's why the direct comparison test it's very impractical. When it works well, it's great. But in this case, you wouldn't do that. So what you do is I'm going to make a fraction of the one I started with and the one I'm comparing to. If that limit as n goes to infinity is finite and not zero, then I know they both do the same. They either both converge or they both diverge. So I already got this one converges. So as long as I can do this limit and show that it's finite, then I know that this one must also converge, that the behavior of this must be like that. So I'm going to do that, and I'm going to show you why this is a pain in the neck too. It's not easy. So I'm going to take the one that I start with, and I'm going to divide it by, now, we're going to do this smart in a minute. The one I start with, AN, divided by the one I compare to. Right? But I don't like that. I don't want to do that. I want to do divided by the one I compare to. I'd rather do that so I can do keep, change, flip. That's exactly what I'm going to do. Right? You're always going to do that. These always end up being okay as long as you compare it correctly. So keep, change, flip. So this is going to change to times. This is going to flip over n squared over 1. Now I'm going to multiply it out, which isn't that bad to do. I'm going to multiply the top. I get n to the 4th plus 2n squared. On the bottom, I have n to the 4th minus 5. And I need to do this limit as n goes to infinity. Now, yes, this is infinity over infinity. And you'd be like, oh, the top has to grow faster. You could sit there and do L'Hopital rules 3 times. Get 4n third, right? And then you would get 12n squared. Like you could keep doing L'Hopital. Eventually this goes away, and eventually this goes away. And you just end up with these. So this limit turns out to be 1. It is finite, and it is greater than 0. Therefore, this one does the same thing as the one you compared it to, which is converge. So this one is converged by the limit comparison test. I found one that I could compare it to. I computed this limit. I showed that that limit is finite and it is not 0. Therefore, they do the same thing. So this is always going to be the way that you do these questions. Now, I have to point that this is annoying to do. And, the thing is, in reality, you don't actually do this. What you actually do is you figure out the one that you compare it to, and you see if that one converges or diverges, and you know what yours does, without having to go through all this rigmarole. But you will have to do this a little bit. So I'm going to show you another example. Let me pause this then. You don't see me erasing the board. Okay, so poof, new problem. Now, you can stare at this question in a second and realize how horrific it looks, and it is. You would have absolutely no hope of trying to do, the A is less than B thing with this monstrosity. It's just not possible. So now I'm going to show you. I'm going to do this a little quicker. I'm going to show you. So this is my AN. I need to figure out what to compare it to. Now, again, you have a radical here, which makes it a lot more complicated. And there's other stuff in there. But for the purposes of determining what you compare to, you are only going to take that and you are only going to take that. So my Bn is going to have radical n6 on top, and it's going to have n4 on the bottom. All these other terms are irrelevant when you're dealing with infinity. So when you take the square root, remember, square root is 1/2 power, right? So you're taking half of 6. You always cut this power in half. So you get n third. And on the bottom, I have n4. Well, once you cross them out, you get 1/n. Our good buddy, 1/n, he fails the p-test. I know that one diverges by the p-test. Now, you are supposed to go and do this whole limit thing, but you know what? This is really what this is the power of that test. Yes, you do have to sit there and show that the limit, when I take this one divided by this one, that I get a finite limit. You don't have to do that here. It's just if you can determine for me. Now, if I'm not your professor, all bets are off. But if you're in my class, then if you can just determine which one to compare it to, and you know what that one does, and then you're slick enough to say, okay, I know that this one behaves like that, so if this one diverges, this one must also diverge. So this one is going to diverge by the comparison test, by the limit comparison test. Even though I'm not showing it, I'm not going to do it. I'm not going to compute that limit. You don't need to, right? I mean, it's just as long as you can determine which one to compare it to, and you know what that one does, yours does the same. This is not a game where I compare it to this one and this one does something different. No, the whole purpose of the comparison test is pick one you know what it does by a previous test, and it's almost always the p-test or geometric. So you pick one that you know what it does, and then yours does the same. All right, yeah, you have to show it's less than the limit thing. It's a pain in the neck. I want to point out something very important though. Like if you were doing this problem and you did this limit and you did get 0, you screwed up and picked a bad thing to compare to. Like this test would fail if you didn't make a good choice here. If I had picked 1/n squared, my limit would have been infinity. Or if I would have picked like 1/radical n, then I would have got 0. Like if you make a poor choice with the limit comparison test, then you will get something funky. But this will never happen, ever. You will never get 0 and you will never get infinity unless you made a bad choice for what to compare to. But all right, so look, these are the tests. But again, overriding thing: pick what to compare to. It doesn't matter what I start with, right? I mean, I could make these look as nasty as I want. I mean, I could start. I'm going to make one up, ice cold, something like that, and then I have 8 plus 5n, and then let's say plus, I don't know, 6n 8. And then you say to yourself, okay, I'm dealing with infinity. All I really care about now, there's a 4 and a 6 there, but I want to use the p-test. That's the whole point. I don't want this 4 and the 6. The 4 and the 6 are relevant. So what? You times that number by 4, you times it by 6. It's not going to matter. What I'm going to compare this one to is 1/n squared. P-test, converge. Therefore, this converges. Doesn't matter. If you put the 4 and the 6 here, then you cannot use the p-test. Then you would have to use the integral test. Same thing, but why do more work for yourself? You always want to create a comparison that you use the p-test or geometric. Depends on what it is, okay? So, the test after this is a little bit more complicated, but really we're running out of the tests soon. There's not many left to do. So again, hopefully this clears up a little confusion. I know in general the comparison test is quite confusing, but the idea of it isn't. It's just doing the things is hard. Doing the inequality or doing the limit can be tricky. But other than that, it's not that bad. All right, so hopefully the lesson video has helped.